if f is a continuous and alpha is a monotone on close interval ab, then integral a to b f of d alpha close interval f of x alpha x a to b minus integral a to b alpha df. Now proof, let p is a partition of a is equal to x0 x1 so on xn equal to b a partition of close interval ab. Choose ti such that xi minus 1 is less than equal to ti is less than equal to xi, and let t is equal to a, tn plus 1 is equal to b. Let q curly bracket starts t0 equals to a, t1 so on tn plus 1 equals to b the another partition of close interval ab. Now s p f alpha equals to sigma I varying from 1 to n f of ti delta alpha I equals to I sigma I varying from 1 to n f of ti square bracket starts alpha xi minus alpha xi minus 1 square bracket close equals to f of ti square bracket starts alpha xi x1 minus alpha x0 plus f of t2 alpha x2 minus alpha x1 plus so on f of tn alpha xn minus alpha xn minus 1 equals to minus t1 alpha x0 minus alpha x1 f of t2 minus f of t1 plus alpha x2 f of t3 minus f of t2 plus so on plus alpha xn minus 1 f of tn minus f of tn minus 1 plus alpha xn f of tn. Adding and subtracting alpha x0 f of t0 plus alpha xn f of tn plus 1, we get s pf alpha is equal to alpha xn f tn plus 1 minus alpha x0 f of t0 minus sigma I varying from 1 to n alpha xi f of ti minus 1 minus f of ti equals to f of b alpha b minus f of a alpha a sigma I varying from 1 to n alpha xi f of ti minus ti plus 1 minus f of ti equals to f of b alpha b minus f of a alpha a minus l s of q alpha f. Equation 1. Now if mu p tends to 0, then mu q tends to 0, and as mu p tends to 0, s of pf alpha tends to integral f of d alpha of the theorem. If f is continuous on closed interval ab, then f belongs to R alpha on closed interval ab, and the limit mu p tends to 0 s of pf alpha equals to integral a to b f of d alpha. Consequently, the limit s q alpha f also exists and tends to integral a to b alpha df for mu q tends to 0. Hence, proceeding the limits when mu p tends to 0, we get from 1 integral a to b f of d alpha is equal to f of x alpha x a to b minus integral a to b alpha f of df, or integral a to b f of d alpha is equals to f of b alpha b minus f of a alpha a minus integral a to b f of integral a to b alpha df.